All right. We're going to start first with grade 11. Just a bit of revision of grade 11. We're doing finance today. So we're doing grade 11 financial maths. Financial mathematics. So there are certain things that we're supposed to know first before we can start with our grade 11 content. So we also have to know when we have, Anna, what is this? What is this formula for? This means we are growing, it's growth. And how do we grow? It's compound, né? It's compound growth. Okay? And we have the sister formula, which is P, 1 minus I, N. But because we have a negative, the difference between these two is just the other one is positive, the other one is negative. The negative part simply tells us it's a decay. But because our number of years, which is n, is also it's an exponent, it means it's compound, still compound. Eh? We are still compounding. Compound. We'll also check how this will be used further to solve problems in grade 12. And we have this one, we call them simple growth. Or decay. So we just realized that every time we have a positive, we are actually growing. Okay? When you have a minus, we are simply decay. So we have A, which is just accumulated amount, the principal amount, then 1 plus IN. So you must check the difference between the two. This is compound. Right? Let me just write it down. Compound, if you look at the compound, it's actually exponential. Right? Or geometric. We can also call it this compound is exponential, or we can call it the geometric, because since where we are coming from number patterns, we can simply see that when n is an exponent, then this will be geometric. Né? So simple growth, those are linear. They form a straight line. Né? Because if you can expand this properly, you will see that we will have something like A is equals to P plus IN, then A can also be written as IN plus there's P this side multiplied by P, and we also have P, and this is just the gradient. Yeah? This will just be a constant, something along those lines. So it's a linear equation, a straight line, it's a simple growth, and because it's a plus again, we're thinking of growth. Yeah. And we have A equals to P 1 minus IN. And this one will be decay. Depreciation. Right? Decay can also be used with like depreciates. Okay. Depreciate. So you're expecting that if you have a principal amount of 10 rand this side, you're expecting to get something more than 10 rand at the end. Okay? But with this one, if you had 10 rand, you're expecting to get something less than 10 rand. Some more. So we can also define the formula so that we know which is which. This is the accumulated amount. This is the amount that you're going to get after the investment, whether the investment has grown, whether the investment is compound or is simple interest. All of them, they mean the same thing, accumulated. Then this will just be our principal amount, is the amount that we normally start with. Principal amount, and this will be the number of years. And in actual sense, I don't like putting the number of years. I can just say the number of, let me just say 10s. Okay. It can be months, it can be weeks, it can be years, it can be depending on what, on how your interest has been compounded. Okay? So your interest normally you'll be given to it, but it must not be a percentage. Yeah? And your interest will actually be I, but you will say whatever you have, the rate, divide by 100. Yeah? You must divide it by 100. So in most cases, and not actually supposed to be in decimals, not a percentage. It will be given to you as a percentage in most question papers, but what you must do, you must actually divide them by 100 so you can be able to see. Yeah? Are we okay? Good. We need to know this before we start with our grade 12 content. Now, let me start with a simple example, which says how long must any amount of money be invested for in order to double at an interest rate of 8.5% per annum, simple interest. Okay, that's an example. That's an example. How long? They want time. That means, now if they say how long you're thinking of this question is looking for n. It's okay. You don't have n. You're looking for n. Any amount. It can be any amount. So we want our amount to be. We can also call our amount to be Rx. X rate. I don't know how much is the amount. That amount must be what? Must be in order for an amount to double. So it means if the amount doubles, if it was X, it must now become 2X. If it was Y, it will now become 2Y. Again, at the interest rate of 8.5% per annum. This is now the interest. This will be 8.5 divided by 100. Which will be 0.085. Okay? Now the other important part is simple interest per annum. At simple interest, when they say simple interest, you're thinking about this formula instead of using this one. Okay? If they said 8% per annum compounded. Then yeah, once they start saying compounded, it means now you're not gonna use the simple one, you're going to use the compound one. Ne? So they've guided you. So it's an investment and it's doubling. I get it. So if it's doubling, now you have to choose between the two. You have two formulas that you have to choose from. You know it's simple interest, but now the amount is doubling. You cannot use the one which is now depreciating. You're going to use the one which is actually growing. I get it. So pick the one with a plus. Good. It's fine. Because the amount is growing, it means the accumulated amount, our A will be bigger than our P. So we're going to have 2x. We're going to be x. We're going to have x this side. Then we have a 1. Then our I, we put that 0,085. Then multiplied by n is the one that we're looking for. I we've discovered that we're actually looking for n. Now, the first thing that you must do, now we are using algebra now. We're dividing by x on both sides. Our x has been divided. Well, once you get rid of this x, we can be able to make n the subject of the formula. Yeah? So x will divide x, and this will just be 2. And you're left with 1 plus 0,085 multiplied by n. We transpose 1 to the left-hand side. That is going to be what? 2 minus 1, which is 1. 0,085, and then we can divide both sides by 0,085.
11,076.
11,076. Now this will be yes. Are we fine? Why is it yes? Because our compound interest, our interest, not our compound interest, our interest was per annum. Okay? So it's going to take this as yes. But if they want this in terms of months and years, this is fine. You're going to have n equals to 11 and 76, 0,76 years. So I'm going to be dealing with this one in terms of months. Okay? So this is just a full years. This is just a fraction of years. Ne? So I'm going to take a 0,76 years. And I'm going to ask myself, in 1 year, how many months do I have? I'm going to multiply this by 12. And everything will be months. 0,76 times 12 is how much?
9,12.
9,12. N will be the same as 11 years. 9 months. 9 years. 11 years and 9 months. Is that okay? Can we move? All right. In the previous grades, we knew how to change the interest rate, né? From being compounded monthly to being compounded weekly, so on and so on. We had a formula for that, né? And the formula was that 1 plus I divided by M multiplied by M. Well, we also discussed what is M for us, ne? It's the same as 1 plus 1 over N divided by N multiplied by N. This is I. Just put them as I. Alright. So we will use this to actually change from one interest rate to the other. From one interest to the other. If now we are having an interest that is given to you for 24 months, it's compounded maybe monthly. Ne? You're given an interest that is compounded monthly, say you must convert it to an interest rate that is compounded weekly. You're going to ask yourself, I have 1 plus the interest that is given to me, and in terms of months, how many months are there in a year? You will write how many months in a year for a year, you're going to multiply by the same number. Okay? And you count this side. Now you're changing to maybe weekly. Let me just say, for example, you have 1 plus the interest rate that you're looking for divided by. If you're going to weekly, you're going to ask yourself how many weeks are there in a year. Then you're going to divide by that number. So you always compare whatever you're changing to a year. Well, I'm also making an example. Let's say we're giving an interest rate of 2.8% per annum compounded semi-annually. Okay, let me just say what will be the interest rate per annum compounded monthly. This is just interest 11. Okay? So you will say, all right, I'm giving this. I need to find this. My interest rate has been is 2.8 per annum compounded semi-annually. So I'll put it aside. This is my M, is the one that I'm looking for. You can put it as any variable. It can be any. It doesn't have to be M and N. It can just be any variable. So I'm looking for this interest rate that must be compounded monthly. So this was just in a year. How many months do I have? How many months? 12. We have 12. Okay? So we'll divide by 12 and also raise it to the power of 12. Okay? Then we come this side. We have 1 plus, what is the interest rate that is given to us is 2.8. Then we said this will just be 2.8 divided by 100. Okay? So either side will just be 0.028. It's fine. We have 0.028, then divided by, you're going to ask yourself, per annum compounded semi-annual, how many semi-annuals do you have in a year? All right. Semi-annual. When you talk about, let me just take you back to student geometry. When you have a semicircle, how many semicircles are there in a circle? You have a semicircle. Do you know what a semicircle is? If you divide it into 2 equal parts, this is a semicircle. Okay? When you have the whole year and you want to divide it into semicircles, it means you must divide it into half. So semi means you're going to half me. Okay? If now they want the semi Nduku, it means you must cut me into half. Ne? I hope you don't kill me though. Ne? So how many are there? How many semi-annuals are there in a year? There will be 2. Again, I'm cutting the year into 2. So there will be 2 semi-annuals. Again. So I'll divide this into 2. Then raise it to 2. About quarterly, you think how many quarters are there in a year? How many quarters are there in a year? 4. Quart, quadro, come 4. You love Audi. You know why Audi is called a quadro? Because it has 4 rings. If you're in the year, you want quarters. Again, when I in your school years, you used to call them what? Terms. Term 1, term 2, term 3, term 4. Again, those are quarters. Ne? So, then this one, you just did algebra. You put this in a calculator and see how much you get. So what I will say is 1 plus I to the m divided by 12 is equals to the root of 12. 1 plus 0,028 over 2 all over to the power of 2. You'll be using a calculator yourself, so I'll just use this. And please remember, in finance, we don't round off. We round off at the end. Remove. We round off at the end. This will be transposed to the side. It's not under the square root. And my IM will simply be whatever I found there, the root of 12 over 2 to the power of 2 minus 1. Everybody will multiply by 12. Then this will give you your interest per annum compounded monthly. Doesn't really have to be monthly every time. It can be quarters, from quarters to annual, from annual to quarters, so on and so on. It is not limited to that.